Alright, so today we will be learning functions, especially functions used as a model. But before that, I want you to think of how can you help or give contribution to countries' fight against COVID-19 pandemic that we are facing today. Yes, we can help or give contribution by formulating a mathematical model that models the number of persons infected by COVID-19, of course, along with some variables or factors. So what is mathematical model? Mathematical model is a process by which we start with the real-life situation and arrive at a quantitative solution using the tools of mathematics. A mathematical model can be used to gain understanding about the real-life situation by learning how the system works, which variables are important to the system, and used to predict what system will do for different values of the independent variable. Hence, mathematical model for these trying times or difficult times is very important because it enables us to adjust to the things that we do to not make this situation worse, and also guides the higher authorities or the government for wise decision making. Since most of the mathematical models are functions, let us refresh our background ideas about functions, and later on we will use functions as models. So let's start our discussion on the definition of functions. So a function is a relation from a set of inputs to a set of possible values or outputs where each input is related to exactly one output. So a function, we can make a function or take function. It's like a machine that whatever you put into that machine, there is a unique outcomes. Like when you cook a rice, so it will not make into a corn. So that is an analogy of a function. So this is a correspondence or relation between the inputs and the outputs. Actually, this function is just a special type of relation. And as we all know, relation is any correspondence between the independent and dependent variables. But this function is a special type, so there is one qualification why this is special type. The qualification is that there must be only one or unique outputs in every inputs. So that makes a function a special type of relation. So let us take this example. Consider two situations here. Situation 1, you're selling candy bars for a school fundraiser. Each candy bar costs $3. In situation 2, you collect data from several students in your class on their ages and their height. So these are the collected data. The question is, which of the two situations are functions or function? So let us examine each situation and use the qualification of the function. So let us integrate that one into situation number 1. So by simplifying this one, we can let the variable x represent the number of candy bars that you sell, and y represent the amount of money you make. So if you sell x candy bars, you'll get $3x, or that is, in equation you can have y equals 3x. So using now that qualification, if you sell 25 candy bars, you'll obtain with $75, and there's none except $75 that you can get. You cannot have $50 if you sell 25 candy bars. You only have $75 So that qualifies the situation 1 as a function. And if you take another value of x, the same will happen. For example, if you take a number of candies, you'll get $3 B number of candies, you have $3B. And if you take all the value of x, the same will happen. Now, let's examine situation number 2. As you can observe in the data collected, if you get 18 as your input and put that in the function, you will have an output of 65, 64, and 67. This disqualifies the situation because our qualification is that there must be only one output in every input. Another, if you get 17 as an input, you'll have 64 and 66 as an output. So, clearly, situation 2 is not a function. And hence, situation 1 is the only function in this example. So what thing can we get with this example? The thing that we can get in this example is that a function helps us to predict what will happen in the future or can give us an idea on what output or outcome will be obtained. So we can now predict what will happen in the future or what will happen if we have this independent variable and then we put that one in the function. We can predict the outcome. Example, in situation 1, you can predict the amount of money obtained by selling the number of candies. For example, you have to sell 25 candies, you will obtain an amount of $75. And if you wanted to have a large amount of money obtained, you have to sell more candies. So in example number 2, you cannot predict because if you have 18 as an input, there are many possible output. So that makes our prediction less reliable and valid. So function can let us predict what will happen or what will be the outcome with this input that we are going to put into our function. And thus, it is important to note that a relation is simply a relationship between two sets of values or data. And not all relations are functions, but all functions are relation. So in situation 1, it is a function and is therefore also a relation. And in situation 2, since it's not a function, it is just only a mere relation. For us to know more about the difference between relation and function, let's take this example number 2. It is known that a relation has a various form. It could either be a set notation form, a mapping diagram, a tabular form, equation form, and a graphing form or graphical form. Since a function is a special type of relation, these forms are also inherited by function. So let us determine which of these forms are function. So let's have first number 1. In the first representation, we are given with a set of ordered pairs. To verify that this is a function, we must ensure or use that qualification, and we can restate that one as this one, that each x value is associated with a single y value. In this example, the first number in each ordered pair is the x value or the abscissa, and the second value in each ordered pair is the y value or the ordinate. So, as can be observed, we are certain that there are no cases where a particular abscissa or X is associated with more than one Y or ordinate. So to make this examination simple, a set is a function if no two abscissas are alike. So if there exists at least two abscissas alike, so the set is not a function. Clearly, number one is a function. So this kind of representation using this set of values is a function. This set is a function. And the second representation, it is in the form of mapping diagram. A mapping diagram is best to use in determining the correspondence between the two sets. To simply investigate this kind of representation, if it is a function or not, there is a modified qualification. Two sets are said to be a function in this kind of representation if it is either one-to-one correspondence, many-to-one correspondence, but not one-to-many correspondence. So if the two sets are in one-to-many correspondence, it is not a function. With this example, since this is a one-to-one correspondence, this representation using these values is a function. Let us now move to the third representation. This is in the form of tabular representation. Tabular representation is best in accounting the XY pair for manual graphing. So, in investigating if it is a function or not, we can use the modified qualifications that we have in the set notation form, that there should be no two abscissas are alike. So since, as you can observe in the table of values, there is no repeating values of X or the abscissa, then this example is a function. The fourth one is in the equation form. In investigating this kind of representation, we can do the same as what we have did in example number 1, that involves candies and the amount being obtained when selling the number of candies. So in this example, it is apparent that any number put in place to X will result in a different value of Y, since the number X is simply being multiplied by 3. So it is obviously a function. The last example is in a graphical representation. A good way to determine whether this graph is a function or not is by using a vertical line test. A vertical line test is simply a vertical line that you have to make in order to intersect this line to the graph. So if you can obtain 2 or more intersections from the graph, it is said to be not a function. But this graph is a function since how many vertical line that you will get intersect it to the graph, you only have one intersection. So this representation using this graph is a function. Finally, we will now use function as a model with this last example that we have. A town's population has been growing linearly. In 2004, the population was 6,200. By 2009, the population had grown to 8,100. Assume this trend continues. Predict the population in 2013 and identify the year in which the population will reach 15,000. To solve this problem, we have these steps. First, determine the variable of interest. Second one, find the rate of change. The third one is to make an equation that is a function that models this situation. And lastly, by substituting the given time, we can get or predict the number of population present in this time. So for the first step, since there are two changing quantities, the population size and time, so these are our variable of interest. So let's proceed to step number 2, finding the rate of change. To determine the rate of change, we will use the change in output per change in input. That is, M is equal to change in output over change in input. This is the same as the formula in finding the slope of the line. The problem gives us two input-output pairs. Converting them to match our defined variables, the year 2004 corresponds to t equals 0 because our t starts from 2004, giving the point 0, 6,200. Notice that through our clever choice of a variable definition, we have given ourselves the y-intercept of the function. So you have 0, 6,200. The y-intercept here is 6,200 because your x equals 0. That means in that point, that point is the intersection of the y-axis in the graph of this line. The year 2009 would correspond to t equals 5 because 2009 minus 2004, you have 5. So t is equal to 5 for 2009, giving the point 5 and 8,100. The two coordinate pairs are 0, 6,200 and 5, 8,100. Recall, using the formula that we have for the slope, this is 8,100 minus 6,200 over 5 minus 0 would have 1,900 over 5. This is equal to 380. This means that the change or the rate of change is 380 people per year. That 380 will serve as our slope of the line, and 6,200 is our intercept, y-intercept. Substituting that into y equals mx plus b, you will have p of t is equal to 380 t plus 6,200. So we have now the equation which is a function that models the situation. So to predict the population in 2013, or evaluating the function at t equals 9 because 2013 minus 2004 is 9, so p of 9 is equal to 9,620. So if the trend continues, our model predicts a population of 9,620 in 2013. To find when the population will reach 15,000, we can set P of t, which is our population size, to be 15,000 and solve for t. This is 15,000 is equal to 380t plus 6,200. So manipulating that, we can have t is approximately equal to 23.158. Then our model predicts the population will reach 15,000 in a little more than 23 years after 2004, or somewhere around 2027. So now we are done with our discussion. So it's now your turn to check your comprehension by answering the exercises that I have posted here. To end this video, I have inserted an interesting video clip, so please watch.
Latest or recent forecast po ng Department of Health ay posibleng umabot sa 75,000 ang kaso ng COVID-19 sa bansa. in a span of 3 months. Ano po ang ating basihan dito, Undersecretary?
Yes, Sec. Andanar, ito po ay isang modeling estimate na ginawa po ng ating mga eksperto kasama ang WHO, ang ating mga epidemiologists din po dito sa ating bansa. At sinasabi po na ang 75,000 ay aabutin natin kung hindi tayo maglalagay ng interventions na appropriate. Ito po ay nakuha natin base po doon sa statistics na meron tayo ngayon among all cases across the globe, na sinasabi po na pwedeng magkaroon ng reproductive rate ang ating virus ng 1 person can transmit it to 2 persons in just one sitting.
So it is clear that there is now a model used. So the last thing that we can do is to follow what the government have said, because in that way we can be a frontliners of our own way. Thank you for watching.